Something is happening out there. Something no astronomer alive has ever seen. A comet from beyond our solar system, 3I Atlas, isn't behaving like a comet at all. It's speeding up when it should be slowing down, changing direction when physics says it can't. And if scientists are right, this could rewrite everything we thought we knew about how the universe works. Hello there, and welcome to the Sleepy Astronomer, a quiet corner of the cosmos where science meets stillness, and the mysteries of space unfold like dreams whispered in the dark. If these journeys through wonder and discovery bring you peace, subscribing to the Sleepy Astronomer helps this constellation of curiosity grow, so more dreamers can drift through science under the same endless sky. Tonight we follow 3I Atlas, a wanderer from another star system, a traveller carrying secrets from beyond the sun's reach, is doing something no comet has ever done before, and no one, not even the experts, can fully explain why. So take a deep breath, because what's coming next might change how you see comets, gravity, and maybe even the boundaries of our solar system itself. This is the Sleepy Astronomer. You begin in stillness, the kind of stillness that only space knows, a quiet so complete it feels infinite. There is no wind, no horizon, no sense of up or down, only the black sea of stars scattered like whispers of memory across an endless night. Somewhere in that immensity, a small light moves, faint but certain. It is not a satellite, not an asteroid, not a reflection from any world we know. It is a traveller. This is where 3I/ATLAS enters the human story. A streak of motion gliding through nothingness, discovered first as a blur on a telescope's image. When astronomers trace its path, they realize something astonishing. It does not belong here. Its orbit, its speed, and its angle all betray its origin beyond the sun's reach. You can almost hear the breathless awe in their data. Another messenger has arrived from the deep between stars. You close your eyes and imagine it, a nucleus of ice and dust no larger than a mountain, drifting for millions, perhaps billions of years through the quiet dark. Around it, particles of frozen gases sleep in crystalline stillness. Each fragment of its body holds stories older than the solar system. Hydrogen that once drifted through interstellar clouds, carbon that once burned inside a forgotten star. In that small cold mass, the universe remembers itself. The comet doesn't hurry, it does not know destinations or deadlines. It simply follows the physics written into its being, gravity's long arc, inertia's unbroken patience. Its path is a whisper, a slow migration from one realm of light to another. You realize how strange it is to think of travel without intent, of movement without goal. Yet in the cosmos, this is the truest kind of journey. When astronomers gave it a name, 3I/ATLAS, the letters meant third interstellar object and the word ATLAS for the survey that first saw it. But names are only handles for the human mind. The comet itself has no need for one. It has existed far longer than any tongue that could speak it. It has crossed distances so large that even the idea of time becomes thin and uncertain. You imagine the frozen traveller brushing through regions where starlight is so weak that darkness feels like substance. If you could stand on its surface, you would see a black so deep that it seems to swallow thought. The sun from there would be a distant ember, not the blazing sphere we know, but a pale dot barely piercing the void. Around you, silence would press from every side, not empty but full of meaning. You might feel the hum of particles colliding, the slow song of the universe still expanding. You might realize that silence is not absence, but presence in its purest form. Earth, so far away, spins unaware. Its oceans breathe, its people sleep and wake, build and dream. Somewhere a scientist leans closer to a computer screen, tracing a curve that doesn't fit. Another looks at the numbers again, her heart quickening. "It's not bound," she whispers. "The comet is free. It is not looping around the sun like the others. It is passing through, unchained by gravity's familiar loops. It has come from elsewhere and it will not return." You imagine the excitement rippling through observatories around the world. Telescopes pivot, cameras hum. Equations begin to bloom like constellations on chalkboards and code. Each discovery is a kind of conversation with the unknown. And 3I/ATLAS, wordless and ancient, becomes a partner in that dialogue. As its faint light grows brighter, you sense something deeper stirring. This visitor is not only a scientific event, it is a reminder of the vastness that holds us. You think of all the distances that separate stars and how, even in that unimaginable emptiness, one fragment of matter can still cross the void to meet another. There is a quiet comfort in that, a sign that connection is woven into the fabric of existence. Comets have always been messengers. In ancient times, they were omens, their bright tails seen as symbols of change or divine will. Now we know they are physical collections of ice, dust, and organic molecules, but the sense of wonder remains the same. You imagine ancient eyes looking up, feeling the same awe you do now, though they lack the words for gravity or interstellar drift. Across the centuries, wonder is the constant. As 3I/A TLAS moves closer to the Sun, its surface begins to warm. Ice sublimates, turning straight from solid to vapor. A tail begins to bloom, a fragile, luminous veil stretching millions of kilometers behind it. You picture sunlight scattering through those particles, turning the invisible into a glowing trail. The comet shines, not by burning, but by surrendering, letting go of itself in light. Every particle that leaves the comet's body becomes part of its story's expansion. In losing mass, it gains presence. You think of how stars too must give up their matter to create new worlds, how galaxies share their dust, how life itself requires release to continue. The comet is teaching wordlessly the same lesson written across the cosmos, that nothing truly ends, it only transforms. You wonder how far it has travelled. Perhaps it came from the cradle of another star system, a world that formed, lived, and vanished before the sun was born. It may have watched alien suns rise and fade, passing through clouds of ionized gas, slipping silently through gravity wells and cosmic tides. In its long journey, it has seen more than we ever will, yet now, for this brief moment, its path and ours align. You picture yourself standing beneath the night sky, the air cold, the world asleep. Above you, somewhere far beyond the reach of eyesight, the comet is there, a speck of ancient light threading across the solar wind. You breathe slowly, feeling your own smallness not as insignificance but as belonging. The same elements that drift in the comet's ice also course through your body. Hydrogen from the first stars, oxygen forged in supernovae, carbon from long-dead suns. You and 3I/ATLAS are made of the same ancestral dust. The thought brings a quiet peace. The universe feels less like a machine and more like a memory, a vast unfolding story that includes every molecule, every orbit, every heartbeat. You realize that to look at a comet is to look at yourself, seen from another form. And as the traveler continues its passage into our inner system, you feel the hush before discovery deepening, that suspended breath before knowledge becomes real. You sense that something extraordinary is about to be revealed, something hidden within its cold body. The light grows stronger, the distance narrows. Soon you will see not just where it came from, but what it carries within. You begin this chapter by following the faint shimmer of 3I/ATLAS as it drifts nearer to the light. The glow you see is not fire, not burning, but reflection, sunlight touching an ancient surface that has not known warmth since before the sun itself was born. Inside that light lies cold, the kind of cold that can preserve memory. You sense it now, the stillness of frozen time, held inside a nucleus no wider than a few kilometers, yet vast in its meaning. When you imagine ice, you think of fragility, melting, vanishing, temporary. But the comet's ice is not the gentle frost that forms on your window, or the crystals that sparkle on a winter's morning. This ice is older, deeper, forged in the vacuum between stars. Temperatures near absolute zero, where molecules slow almost to stillness, have turned simple gases, water, methane, ammonia, carbon dioxide, into ancient stone. You can almost hear the faint creak of that matter, a soundless pressure of ages pressing into silence. Every molecule inside that frozen heart has a story. Hydrogen, the simplest element, was born in the first seconds of the universe, in that bright and unimaginable dawn after the Big Bang. Oxygen came later, birthed in the fiery deaths of massive stars. Somewhere far from here, a supernova scattered that oxygen into space, where it drifted for eons until it met a particle of hydrogen, forming water in the chill of interstellar dust. that droplet, invisible and weightless, joined others, binding into the substance that would one day become part of 3I/ATLAS. You realize in this moment that what you are witnessing is not merely a comet, but a capsule of creation. It carries within it the chemistry of beginnings, the same ingredients that on worlds like Earth gave rise to oceans, clouds, and life. When the sun warms it, that ice releases not only vapor but memory. Each molecule that escapes into sunlight is a fragment of time dissolving back into the story of the cosmos. Astronomers call this sublimation, the process by which a solid turns directly into gas, skipping the liquid stage. But in the still poetry of the universe, you might think of it as exhalation. The comet breathes for the first time in millions of years. Its body satin out the ancient cold, creating a halo of vapor that surrounds it. A coma, they call it, glowing faintly against the black. Through a telescope, that coma is a soft sphere of light, delicate as mist. Within that view, sunlight scatters and ionizes particles, creating colour. Faint greens and blues, born from carbon compounds and excited oxygen. The colours are real, measurable, chemical, and yet, to your eyes, they feel emotional. The comet's quiet joy at being seen again. You imagine how lonely it must have been, adrift in interstellar space with no warmth, no light, no one to witness its passage. And now it glows. As you think about that loneliness, you realize that space itself is a kind of mirror for emotion. The cold between stars is not emptiness. It is potential. Within that potential, ice can hold the blueprint of life. Molecules like formaldehyde and methanol, amino acids precursors, locked in crystalline quiet. When comets strike young worlds, they deliver these ingredients, seeding planets with chemistry that might one day awaken. Perhaps 3I/TLAS has carried such seeds through countless light years, never knowing it holds the possibility of life. You picture its surface, jagged, grey, dusted with a thin layer of carbon-rich grains. Beneath lies glassy ice, fractured by time and impact. The sunlight reaches only millimeters deep before the heat fades, swallowed by the cold within. Beneath that, the temperature remains nearly constant, around 30 degrees above absolute zero. At that point, matter barely moves. Time feels stopped. The comet's heart beats in geological slow motion. You imagine reaching out a hand, gloved, fragile, and touching that surface. The cold would not feel like any you've known. It would be beyond sensation, a silence that numbs even thought. That cold is the same condition that preserves molecules from decay, protecting them from radiation and chemical reaction. It is the cold that allows memory to survive. Inside the ice, gases form pockets, tiny voids where molecules are trapped. When the comet nears a star, those pockets rupture, sending geysers of vapor into space. Jets burst outward, pushing the comet slightly off course, creating unpredictable wobbles in its trajectory. Astronomers observe these deviations and calculate the forces behind them, reading in the motion the invisible breath of sublimation. In that data lies a kind of heartbeat, irregular, alive. You realize that even in the deepest cold, change is inevitable. The comet cannot stay frozen forever. Proximity to light always transforms. Perhaps that is the quiet metaphor of 3I/ATLAS. That warmth, though it brings loss, also brings expression. Without heat, the comet would remain unseen, a dark stone adrift. With heat, it becomes visible, luminous, meaningful. You breathe with it, feeling that paradox in your own life. How moments of vulnerability bring brightness, how loss becomes illumination. Astronomers studying the spectrum of its light detect ratios of deuterium and hydrogen, subtle clues that reveal the comet's birthplace. The measurements suggest that it formed in a region colder than any in our solar system, where ices condense from gases that never warm. This means that 3I/ATLAS likely originated near another star, in a circumstellar disk now long gone. Its chemistry bears the signature of an alien nursery. You imagine that distant sun, now perhaps extinguished, and feel the weight of time again, not as burden, but as depth. The idea humbles you, a single speck of frozen dust, surviving the death of stars, drifting through billions of years, and now, in your lifetime, glimmering briefly within reach of human eyes. You are witnessing persistence, the endurance of matter through eras no mind can count. The cold becomes not lifelessness, but a form of devotion, the universe holding itself together through stillness. In that stillness, there is peace. The comet continues its slow approach, its surface beginning to change as the sunlight grows stronger. Crystals shift, gases awaken. The coma swells into a translucent sphere that breathes with every kilometre closer to the sun. Observers record its brightness increasing, but no one can predict what will happen next. Will it survive its encounter, or will the warmth undo it? You breathe out slowly, letting the question hang. The comet, still wrapped in its ancient cold, is about to meet heat for the first time in eons. Something inside it will transform, perhaps gently, perhaps catastrophically. You sense the turning point approaching, that fragile balance between endurance and change, and as 3I/A/TLAS drifts into the growing light, you realize that the story of ice is never just about cold, it is about memory meeting warmth. You watch quietly as it begins to shimmer more brightly, a frozen memory preparing to wake. Soon you will see what happens when that cold meets the pull of the sun, and how even gravity can falter when faced with something born beyond its reach. You open your eyes to motion, not the slow drift of ordinary comets, but something faster, sharper, more defiant. 3I/TLAS cuts across the solar system like a thought that does not belong to the sentence it's in. You can almost feel the confusion in the observatories that first charted its path. The data points would not fit. The orbit could not close. The curve on the screen refused to loop back toward the sun. It extended outward endlessly, like a question written across the sky. Most comets are creatures of repetition. They belong to the sun in a delicate way, captured by its gravity, returning again and again in long, patient ellipses. They leave, but they always come home. 3S/TLAS is different. Its trajectory is hyperbolic, open, unbound. The numbers tell the truth that words can only suggest. This comet is not one of ours. Its eccentricity, the measure of an orbit's stretch, is greater than one. Beyond that threshold, mathematics whispers escape. You picture gravity as a soft hand that reaches out to hold the planets. It curves space gently, folding it into orbits, into circles and ellipses that keep everything in motion yet near. But 3I/A/TLAS passes through that embrace untouched. Its speed is too great, its angle too steep. The hand closes too late. The comet slides through the system like light through a window, slowed but never stopped. Astronomers, tracing its path backward, try to find a point of origin. They find none. No region of the Oort cloud matches, no resonance with Jupiter's influence, no sign of gravitational scattering from the outer planets. When they trace it forward, the same mystery persists. It will never return. Once it leaves the solar system, it will vanish again into the quiet interstellar dark. You sense in this trajectory something almost emotional, the physics of non-belonging. The shape of its path is not random. It obeys Newton and Einstein perfectly, yet it feels rebellious because it moves beyond the familiar rules of our celestial family. Like a visitor who passes through a room without stopping to speak, it leaves a kind of wonder behind, a sense that the universe is more open, more connected than we imagine. You close your eyes and visualize its orbit as a line carved through space-time itself. It begins in a region we cannot see, enters our system from the direction of a constellation, bends slightly around the sun, and departs toward another unknown. In that bending lies the smallest signature of our star's gravity, a kiss of light that deflects its course by a fraction of a degree. That angle, measured with precision, becomes a clue. From it, scientists calculate its speed, over 60 kilometers per second relative to the sun. That number is not just velocity, it is history. To move that fast, 3I/A/TLAS must have been ejected from its home system long ago, perhaps by the gravity of a giant planet or the death throes of a distant star. Somewhere long before human eyes existed, a cometary fragment was thrown loose from its sun, carrying with it the momentum of an ancient separation. Across the dark it wandered, untouched and unseen, until now. You imagine the solitude of such a journey. Millions of years between stars without a source of light or warmth. drifting through dust clouds and magnetic fields. Each passing cosmic ray carved faint scars into its surface. Each encounter with interstellar atoms left chemical traces, microscopic tattoos of its voyage. It has been sculpted not by collision, but by emptiness itself. And yet, here it is, inside the sunlight of another world. It makes you think about direction, how even when paths seem aimless, there is still a current underneath. The comet's motion is a reminder that everything travels somewhere, even if that destination lies beyond what can be seen. The laws of motion are both strict and gentle. Nothing can stop a body once it has been given speed. Nothing can erase its momentum but the soft persuasion of gravity. Astronomers, curious and humble before its mystery, calculate its future. They project its path decades ahead, centuries even, and find that it will soon pass beyond the heliosphere, the invisible bubble of solar wind that marks the sun's influence. When it crosses that line, it will rejoin the interstellar medium, carrying traces of our system's dust with it. It will become, once again, a traveller of the spaces between stars. You feel a strange tenderness for it. The comet does not know that it's being studied, that its numbers and coordinates are whispered between scientists across the globe. It only moves, obeying the equations that shape the universe. There is something comforting about that purity, motion without motive, freedom without rebellion. Still, you can't help but sense a message in its path. The hyperbola it draws is a shape of passage, not of return. Perhaps it mirrors something human, the way experiences pass through us, never looping back the same way. We are all travellers of open curves, living in orbits that rarely close. The comet becomes a mirror, showing how motion can be both departure and belonging at once. As 3I/TLAS sweeps closer to the sun, its speed increases, as if exhilarated by gravity's pull. But even as it accelerates, it never loses its freedom. It will swing around the star, shedding some of its icy surface, glowing brighter than ever, and then continue outward, into the dark once more. The sun, vast and powerful, can bend its path but cannot claim it. In that image lies a profound truth. Even gravity, the strongest of bonds, has limits. Scientists measure its exact trajectory, feeding data into equations of celestial mechanics. Computers hum, graphs curve across glowing screens. Somewhere in those lines, the mystery persists, a path that shouldn't exist but does, a movement that belongs to no home, bound only by the laws that made all movement possible. You stand beneath the night sky, aware that somewhere up there this traveller is tracing that impossible path in real time. You can't see it, but you can feel its presence in the quiet air, like a thought that refuses to fade. And as it moves beyond calculation, beyond reach, you sense the next question rising. If the comet can travel free of gravity's hold, what other rules might be waiting to be rewritten in the dust it leaves behind? You imagine the dust first. It hangs around the faint body of 3I/TLAS like a cloud made of breath and memory. Through telescopes, it looks ordinary, a hazy coma, the thin veil most comets wear when they approach sunlight. Yet when the light is analysed, something begins to whisper differently. The grains reflect and scatter in ratios no instrument has seen before. The patterns of brightness do not fit the models of familiar dust. This dust, scientists realise, is not from here. Its fingerprints, the spectral lines, the scattering angles, belong to matter that formed far from our sun's nursery. Interstellar dust has its own dialect, and 3I/ATLAS carries an accent from beyond our local space. The elements are the same, carbon, oxygen, silicon, iron, but the proportions tell another story. The isotopic balance in a few atoms is tilted, as if written under a different cosmic temperature. You imagine each tiny grain as a letter from another star. Together they form sentences written before the sun existed. A comet like 3I/ATLAS is a messenger, but its message is not made of words, it is written in chemistry. Ratios of oxygen 17 to oxygen 18 become phrases. The amount of deuterium, heavy hydrogen, becomes punctuation. It is a script that only starlight can read. When sunlight hits this dust, the photons scatter, bouncing off surfaces rougher than sand, smoother than frost. Each collision tells physicists how porous the grains are. Some are so fragile they would crumble if touched by a human fingertip. They are like the ash of a forgotten fire, preserved only because space is mostly empty. In the lab, scientists compare these reflections with those from comets born within our solar system. They find subtle differences. The refractive index, a measure of how light bends through material, shifts slightly. The colours redden in ways that suggest organic coatings, long chains of carbon, perhaps tholins formed by ultraviolet light acting for millions of years. These molecules are older than the planets. The thought settles slowly in your mind. This dust has crossed the interstellar gulf. It has floated through magnetic fields, cosmic rays, and the cold of near absolute zero. It has been struck by particles moving faster than bullets. Yet it survived, and not as rock, not as ice, but as memory. In every grain there is a record of its birthplace. Stars forge heavier elements in their cores, and when they die, those elements drift outward. Some join nebulae, others condense into planets or comets. 3I/ATLAS might have formed around a distant sun long extinguished. Its dust still carries the balance of that star's chemistry, the echo of a system gone silent. Astronomers call this process isotopic tagging. It means that atoms remember the environments that made them. The ratio of nitrogen isotopes can tell whether a grain cooled in a dense cloud or in a thin one. The ratio of hydrogen to deuterium can reveal the temperature of its birth. Through these clues, scientists reconstruct stories billions of years old. You picture it simply. Every bit of dust is a postcard stamped by physics, mailed by time. Some postcards travel farther than others. Most never reach us, but 3I/ATLAS did, and when it passed through the inner solar system, Earth's telescopes caught a few faint signals, brief flashes of reflected sunlight, like envelopes opened mid-journey. Even the dust that breaks away from the comet's surface tells part of the story. The grains stream behind it, forming a tail that curves under solar radiation pressure. Each particle moves slightly differently, depending on its size and charge. The tail becomes not just a streak of light, but a laboratory of trajectories. From this, astronomers measure the strength of the sun's wind, the flow of particles that fills the heliosphere. You realize that 3I/ATLAS is teaching two lessons at once. It is revealing its own composition, an alien fingerprint, and also revealing how our solar system interacts with visitors. The way the dust scatters and accelerates under sunlight becomes a mirror for our star's behavior. We learn about ourselves by studying what is not from here. Imagine being near the comet, though no spacecraft could follow it for long. The dust would form a faint mist, each grain a microscopic mirror. If you could reach out your hand, the particles would drift through your fingers like cold smoke. They are too small to feel, yet they carry more history than any rock on Earth. Some researchers suspect that such interstellar grains could seed life's chemistry wherever they land. Organic molecules, carried across the void, might one day fall onto a young planet's ocean. The dust of comets becomes the dust of beginnings. On Earth, meteorites already show traces of amino acids, the building blocks of proteins, formed in space long before life started here. It is easy then to imagine that 3I/ATLAS carries the same potential. But not all stories are about origins. Some are about endurance. The dust of 3I/ATLAS has endured distances that defy language. Light itself, moving at nearly 300,000 kilometers per second, would take years to cross the space it has traveled. The grains have wandered perhaps hundreds of millions of years through the calm between galaxies, and still they shimmer when touched by sunlight. You find comfort in that image. Something so small can survive so long, carrying its quiet code across the coldest places known. The dust doesn't speak loudly, but when the instruments listen carefully, it tells everything it knows. Scientists collect its spectra, lines and intensities plotted on a screen. The data are numerical, precise, almost clinical. Yet behind each line is a wonder, atoms vibrating in harmony, light remembering where it has been. To the human ear it might sound like a whisper, but in the language of physics, it is a full conversation. You breathe slowly, imagining that whisper continuing as the comet drifts away. The grains scatter into wider orbits, fading until they become part of the background dust that fills interstellar space. One day, perhaps, they will fall toward another star, another observer, another question. The night sky above you holds countless such travelers, dust from comets, from planets, from stars long gone. You're breathing some of it now. Every inhalation brings in atoms once part of something far away. In that way, 3i/ATLAS is not only visiting you through a telescope, it is already here, in trace amounts, in the air, in the soil, in your body. You close your eyes and see the dust drifting, each grain carrying a secret signature of the universe's past. It does not hurry, it does not fade, it simply continues, a whisper made of matter, crossing light years with patience. And somewhere beyond the last reach of the sun's pull, 3i/ATLAS moves on, its dust spreading behind like pages of an unfinished book. You sense the next chapter is already forming, a faint glow beginning where reflection meets light. The light begins quietly. It does not blaze, it does not burn, it simply reflects. You imagine sunlight leaving the sun, a stream of photons travelling for centuries through the cold dark. When it finally reaches 3i/ATLAS, the journey ends with a soft touch, a glimmer brushing against ice and dust. That touch, that small meeting of star and traveller, creates the faint breath of light that makes the comet visible at all. Unlike the fiery comets of our solar system, 3i/ATLAS glows not because it burns, but because it listens. It listens to light and answers by scattering it. Every photon that meets its surface changes direction, bouncing outward like a quiet echo. Through telescopes on Earth, that echo becomes a point of shimmering green-blue, the colour of reflected distance. The light is old, but it feels new when it meets the comet. Photons from the sun travel for about 8 minutes to reach Earth, but some of these same photons continue beyond, crossing billions of kilometres. When they strike the frozen nucleus of 3i/ATLAS, they reveal shape, texture and motion, information hidden in darkness until this moment. In this faint glow, astronomers see the comet's heartbeat. You imagine the comet as a mirror carried through eternity. Its surface, rough and pitted, holds ice that has never melted. The sun's rays strike these frozen plains, and for a moment, the light scatters across space, a whisper made visible. Each reflection is slightly different, shaped by the angle of the surface, the density of dust, the purity of the ice. Together, they form a shifting halo that surrounds the nucleus like breath in winter air. In the silence of space, that breath moves outward. The particles of gas and dust released by gentle warming drift slowly away, creating the comet's coma, a glowing atmosphere that can stretch thousands of kilometers. Here, light and matter become partners. The gas fluoresces under solar radiation, re-emitting energy at precise wavelengths that tell scientists what elements are present. Carbon, oxygen, sodium, cyanogen. These faint emissions make up the comet's spectral voice. Every colour in that glow is a clue. A faint green hue suggests diatomic carbon, C2, excited by sunlight. A bluish tint marks the presence of CN, a compound that forms from nitrogen and carbon in the comet's thin atmosphere. These are not invented colours, they are the comet's vocabulary, its way of speaking in physics. By measuring the brightness and spread of these hues, astronomers learn how much material is being released, how fast the comet is changing, and how active it becomes as it nears the sun. The glow is faint, almost invisible to the naked eye, but it means everything to those who study it. In laboratories, scientists simulate sunlight and ice, recreating miniature comets to compare their reflectivity. They find that 3i/ATLAS is darker than expected. It absorbs more light than it returns. The albedo, or reflectivity, is low, suggesting surfaces coated with complex organics, tar-like residues left behind by cosmic radiation. These dark coatings absorb most photons and scatter only a few. Those few are what we see from Earth, the comet's faint breath of light. You can picture that contrast. A dark traveller moving through darker space, visible only because it carries light it does not own. It does not generate energy, it only borrows it. The sun lends brightness to every comet, every planet, every world. The glow of 3i/ATLAS is a reminder that illumination in the universe is often borrowed. Even the direction of the light tells a story. Some photons scatter backward toward the sun, others scatter sideways toward our telescopes. The scattering pattern reveals the shape and size of dust grains, whether they are smooth spheres or jagged fragments. Through this analysis, astronomers build models of the comet's physical nature without ever touching it. Light, in this way, becomes a messenger that carries both beauty and data. As you think about this, a quiet idea forms. Reflection is a form of connection. The comet, far from home, still interacts with our star. It does not resist the light, it welcomes it. That meeting creates something neither could make alone, a glow that travels across the dark, bridging distances impossible to cross by any other means. Sometimes 3I/ATLAS brightens slightly. Astronomers notice small fluctuations, outbursts that last a few hours or days. These may come from jets of gas erupting beneath the surface or fragments breaking free. Each outburst changes how light scatters, producing flashes that ripple through its tail. These changes are subtle, but they remind scientists that comets are alive with motion, always adjusting to the heat, the pressure, the invisible winds of space. The faint breath of light is not steady, it flickers. Telescopes capture this rhythm, and data curves rise and fall like a slow pulse. Through that pulse, researchers can measure rotation, how long it takes the comet to turn once on its axis. 3I/TLAS spins, though slowly, and as it rotates, different parts of its surface catch sunlight. The glow changes accordingly, as if the comet inhales and exhales through brightness. In this light you can find something familiar, a quiet metaphor for being alive. To shine not from within, but from what you receive, to turn slowly, changing how the light meets you, to exist in motion, carrying both darkness and reflection. Even from across billions of kilometers, the behavior of a comet feels close. The photons that touch 3I/ATLAS continue outward after reflecting. Some reach the lenses of telescopes, others scatter into the vastness. A few, incredibly, reach your eyes. When you look at images of the comet, you are seeing light that has traveled from the sun to the comet, then from the comet to Earth, then through your own pupils into the back of your mind. You are literally seeing what it saw, and as you let that thought rest, you realize that all seeing is connection. Light, reflected, shared, remembered. The faint glow of 3I/TLAS is both distant and immediate, both ancient and new. It is proof that the universe, no matter how vast, is still bound by light. Somewhere beyond the limits of our instruments, that glow fades again into darkness. The comet keeps moving, silent, invisible to most eyes. But even in the dark, it carries the same relationship with light, a readiness to reflect when called. You breathe out softly, thinking of that constant exchange, of light that travels, touches, changes, continues. The comet drifts onward, and the sun still shines. Between them, a quiet pull begins to form, the tension between gravity and freedom. It is almost time to see what happens when that pull begins to lose its hold. You imagine gravity as a hand, open, steady, reaching through space. It holds planets, moons, and comets in long invisible threads. Most obey its pull completely. They orbit, they return, they fall. But 3I/TLAS is different. It slips through the sun's grasp, moving too fast, too free to stay bound. It belongs not to our star, but to the space between stars. The term astronomers use is hyperbolic trajectory. It means the comet's path bends but never closes. Ordinary comets follow ellipses, returning after decades or millennia. A hyperbolic path is a wave that never circles back. The sun's gravity slows 3I/ATLAS slightly, but not enough. Its speed, more than 40 kilometers per second, ensures escape. Freedom in celestial mechanics is a matter of numbers. You picture this moment as a quiet conversation between motion and gravity. The sun reaches, but the comet keeps going. There is no struggle, no defiance, only continuation. The mathematics of the scene are elegant. Velocity greater than escape velocity. To remain bound to the sun, an object must travel slower than this limit. To leave forever, it must exceed it. 3I/ATLAS does. It helps to imagine space not as emptiness, but as a vast landscape of gentle curves. Einstein taught that gravity is not a force pulling things together, but the bending of space-time itself. Massive objects like stars and planets create dips in this cosmic fabric. Smaller bodies follow those dips like marbles rolling around a bowl. But if a marble rolls too fast, it climbs the curve and escapes. That's what 3/8LAS is doing, rolling up the slope of the sun's gravity and out into interstellar space again. This movement carries a quiet lesson about balance. Every orbit is a conversation between falling and missing. The moon falls toward Earth constantly, but because it moves forward fast enough, it keeps missing the ground. That endless missing is what we call orbit. When 3I/8LAS passes near the sun, it also falls, but its forward motion is too great to let it turn back. It misses forever. You might think of freedom as chaos, but in physics, freedom has precision. Every fraction of speed, every degree of angle matters. When the comet entered our solar system, its velocity was just above the escape limit. The gravitational fields of Jupiter and the Sun bent its path slightly, but not enough to trap it. It brushed against our star's reach and kept moving, carrying the imprint of those forces like soft fingerprints in its orbit. Astronomers trace this path with equations that seem almost musical, patterns of curvature and acceleration plotted through the coordinates of space. They find that 3I/8LAS approached from a direction high above the plane of the planets, then looped inward and outward again, leaving at a slightly altered angle. The change is small but measurable. Gravity leaves its mark even when it cannot hold. You might wonder what that means for time. Near massive bodies, time slows slightly, a phenomenon called gravitational time dilation. As 3I/8LAS passed close to the Sun, the seconds it experienced would have stretched imperceptibly compared to ours. When it leaves, time returns to its normal pace. Even in freedom, the comet carries that subtle distortion, a memory of slower light and deeper space. The numbers tell a clear story. The sun's escape velocity at the comet's closest distance is about 42 kilometers per second. 3I/8LAS moves just above that, perhaps 44 or 45. It's a small difference, but in space that difference decides whether an object becomes captive or eternal traveler. That tiny surplus of motion is the measure of liberty. To think of gravity missing its hold is not to think of weakness, but of harmony. The sun cannot keep everything. It was never meant to. Some matter belongs to the interstellar sea, and some merely visits the shallows near our star before drifting away. The solar system is open-ended, always exchanging with the galaxy, dust, light, and sometimes comets that come and go like thoughts passing through a mind. You imagine standing somewhere beyond Earth, perhaps near Jupiter's orbit, watching 3I/8LAS glide by. The sun shines behind it, the planets move quietly in their circles, and this one object crosses through their orderly motions like a free note in a song. It doesn't disturb them, it just adds a temporary melody. After it leaves, the solar system continues unchanged, but not untouched. There is a strange beauty in that passing. To see something move beyond control reminds you that the universe isn't built on permanence. Stars form and die, planets drift, galaxies merge, and even gravity, the strongest bond we know, has limits. It holds, it bends, but sometimes it lets go. You might think of your own life in that image, the balance between what keeps you anchored and what lets you move. Gravity keeps your feet on the ground, but imagination, curiosity, and wonder allow you to travel beyond it. The comet is doing the same, carried by the inertia of its beginning, by a push so old it might have come from another sun's farewell. Astronomers wonder how it gained that speed. Perhaps it was ejected from its home system after a close encounter with a giant planet. In those distant places, gravitational slingshots can occur, interactions where one planet gains energy while the other loses it. Over time, such encounters can fling comets entirely free of their stars. 3I/8LAS might be a product of that ancient dance, expelled and set adrift millions of years ago. As it travels, the comet becomes an instrument for understanding how stars share material with one another. Each unbound object adds to the invisible bridge connecting planetary systems. Space is not isolation, it is exchange. The dust and ice of 3I/8LAS carry traces of atoms forged elsewhere, now passing through our domain. Someday some fragment may be pulled into another system, another sun. Gravity releases, but connection continues. The mathematics of this escape have been tested again and again, yet they remain astonishing. For something so small to overcome the pull of a star requires exact alignment of motion and angle. Too slow and it would fall inward, evaporating near the sun, too fast, and it would never have approached close enough to be seen. 3A/TLAS moves within that narrow window, the perfect compromise between arrival and departure. You can think of this moment as the center of the comet's story, the point where its path bends closest to the sun, where gravity tries hardest and fails most beautifully. The tension between attraction and release defines its shape, its speed, its destiny. The entire solar system participates in this silent choreography. The pull of the sun, the subtle nudge of Jupiter, the soft resistance of light pressure from photons. And then, after the brief encounter, the comet begins to drift outward again. Its speed remains nearly the same, but its direction shifts, tilted slightly by what it has passed through. The sun grows smaller behind it, the planets fade into pinpoints. Gravity lingers like a memory, not as a chain. You picture the invisible thread stretching, thinning, then vanishing. Beyond the heliosphere, beyond the wind of the sun, the comet will enter interstellar space once more. There, the curves of gravity flatten out. The stars still pull, but faintly, distantly, like music too soft to hear. And as 3I/TLAS moves into that quiet, it carries with it everything the sun tried to hold: warmth, reflection, motion, and the memory of light. Ahead lies nothing but open dark, yet in that freedom there is still motion, still purpose. You let the thoughts settle, calm and certain. Even in release, gravity leaves a trace. The comet is free now, but its path still hums with the music of the sun's pull. Somewhere inside that silence, another rhythm is beginning, the movement that will soon be heard not in numbers, but in motion itself. The universe does not speak in words. It hums. You may not hear it through the air, for in space there is none. Yet if you could listen with your mind, the motion of every body, from drifting dust to galaxy, would be a note in an endless composition. The planets circle the sun like the slow pulse of drums, moons whisper harmony, and comets, rare and restless, play the quick, bright tones that flicker across the staff of time. 3I/ATLAS enters that Ondas orchestra as an instrument out of place. Its orbit cuts through the solar system not like a familiar melody, but like an unexpected chord, sharp, irregular, beautiful. You imagine its trajectory plotted against the dark, a curve of mathematics that no ear can hear but every mind can feel. Its music is not played in time as humans understand it. It is measured in distance, in acceleration, in gravity's pull and release. Its rhythm is the story of motion itself. You close your eyes and imagine what such a rhythm feels like. One part of you drifts with the planet, predictable, secure. The other part races with 3I/ATLAS, quick, free, unsynchronized. Between these two sensations lies a truth. The universe does not favor harmony that stays the same. It prefers change, dissonance, evolution. What sounds strange at first becomes in time the very heart of the song. Astronomers too listen for this hidden rhythm. They do not use ears but equations. They convert brightness into velocity, arc seconds into melody, the subtle bending of starlight into a pattern of pitch. Each observation of 3I/TLAS becomes a note recorded in invisible ink, data that must be translated before it can be understood. And when they gather the full score, the scientists discover that this comet sings in a key never heard before. Its orbit does not repeat. Its speed breaks the familiar tempo of solar comets. It passes too swiftly for resonance, too briefly for chorus. It is a solo played once in eternity. You picture the comet as an object in motion, not a point of light, but a dancer in vacuum. Every turn of its tail is a flourish of movement. Every curve through sunlight and shadow is choreography written by gravity and heat. The gases streaming from its surface form shapes that shift like breath, expanding, fading, renewing. In this silent ballet, even the smallest detail is part of the rhythm. The flicker of reflection, the drift of dust, the invisible tug of the sun's distant hand. And still, what draws you is not only its motion, but its imperfection. The music of 3S/TLAS is slightly out of tune. Its orbit defies the tidy loops of planetary order. Its brightness does not follow the rules. Its composition hints at unfamiliar chemistry. Like a musician who bends a note just slightly off the scale, The comet challenges the ear of the universe. It reminds you that creation is not made of perfection, but of difference, that beauty emerges not from repetition, but from surprise. You imagine what the universe might sound like if its motions were translated into music. The deep bass of Jupiter's gravity, the violin tremor of solar wind, the faint metallic whisper of cosmic rays streaming through the interstellar void. And amid all that vast symphony, 3I/ATLAS, a comet that hums in its own measure, neither lost nor found, but existing precisely between belonging and freedom. You realize that such music could never end. It would continue long after ears and minds have fallen silent, vibrating through the empty dark. There is something peaceful about that thought. You do not need to understand every formula or chart. It is enough to sense the pattern, to know that emotion itself is a kind of song, and that the universe hums whether anyone listens or not. The comet, gliding between suns, becomes the sound of that truth. It moves not to reach a destination, but simply because motion is its nature. Somewhere in that realization, you begin to hear your own rhythm. The pulse of your blood mirrors the orbit of celestial bodies. Your breath rises and falls like tides on a planetary shore. Even your thoughts drift in cycles, questions forming, fading, returning. The boundary between yourself and the comet grows thin. You both move within larger patterns, unseen but continuous. The harmony you seek is already playing within you. Astronomers continue to observe, tracing the tempo of the comet's arc. The numbers they record form a line, acceleration, distance, magnitude. But you understand that beneath those symbols lies something more alive. It is the same awareness that music brings, that structure and emotion can coexist, that order and mystery are partners, not opposites. To study 3I/ATLAS is to listen patiently for a song that has no beginning or end, only motion. Sometimes late at night, you imagine the data turning into sound. Each line of observation a note, each discovery a chord. You listen to the composition unfold, slow at first, then swelling, then fading into silence. And in that silence, the true music begins, the quiet awareness that you are part of something moving, vast and gentle. You realize that wonder itself hums at a frequency you can almost feel but never quite measure. The comet continues on, far beyond where light will easily reach. Yet even as it disappears, its motion remains part of the universe's rhythm. Like an echo that never fades, it shapes the harmony of all that follows. Its path curves into the infinite, and you sense that somewhere in that infinity, another melody is beginning, a new transformation waiting to be heard. You breathe in, feeling the pulse of unseen orbits. You breathe out, and the silence deepens. In that stillness, the music of 3I/ATLAS continues, not as sound, but as presence, as memory, as the graceful truth that everything that moves is singing. And as the final note drifts into quiet, a new image begins to take shape. The comet changing, reshaping in the light. Its motion becomes metamorphosis. Its music turns to color. You wonder what happens when a traveler not only moves, but begins to change its form. You have followed 3I/ATLAS through some silence and rhythm, through the unseen music of its motion. Now, as sunlight reaches it, something begins to shift. The comet's brightness, once steady and faint, flickers and swells, its tail bends, its body reshapes. What once seemed solid reveals itself to be transient, sculpted by light itself. Most comets do this, you're told. As they approach the warmth of a star, their frozen surfaces awaken. Ice turns to vapor, dust breaks free, and the nucleus releases what it has held for eons. But with 3I/ATLAS, the change feels different, faster, deeper, unpredictable. It is not simply shedding, it is transforming, as if sunlight is rewriting its form in real time. You imagine the comet as a face made of frost and gas, changing expression with every breath of heat. At one moment it glows a pale green, the next a bluish white. The colors are more than beauty, they are chemistry singing in visible wavelengths. Carbon-based molecules burn into emerald. Ionized water releases ultraviolet whispers. Every hue, every foam you flicker, is a language of reaction, a dialogue between matter and energy. Astronomers watch with wonder, They calculate the rates of sublimation, the pressure of solar wind, the drag of radiation. Yet even in numbers there is poetry, for what they are truly witnessing is impermanence. 3S/TLAS is not resisting change. It is defined by it. Its transformation is not failure but fulfillment. A comet's purpose, if it can be said to have one, is to reveal what happens when the ancient meets the immediate. When something born in cold darkness greets the warmth of a star, you feel that encounter as a mirror within yourself. There are moments in life when light too changes your shape, when warmth or understanding arrives suddenly and alters who you are. The comet teaches that transformation is not loss but release. It shows that the stability is not always strength, and that beauty can come from surrendering to motion. Through telescopes on Earth, the comet's image wavers, not static but breathing. Photographs taken days apart reveal new contours, shifting tails, bursts of material expanding like soft explosions. The astronomers trace jets of vapor spraying from its sides, tiny geysers sculpted by sunlight and spin. The data suggests that beneath its crust, fractures are forming, that heat is carving deep channels through ancient ice. What emerges is both destruction and creation at once. You close your eyes and picture this process, not as violence, but as metamorphosis. The comet, far away, glows in silent dissolution. Its fragments catch the sun and scatter light across millions of kilometers. The tail lengthens like a river of mist. It looks as if the comet is exhaling, letting go of what it no longer needs. Each molecule that escapes becomes a seed of new beauty, diffused through the cosmic dark. The word comet comes from the Greek kometes, meaning long-haired. The ancients saw these travelers as omens, their streaming tails like celestial hair catching fire. Today you understand the physics behind the glow, the dust, the plasma, yet the awe remains unchanged. To see something altering before your eyes, and to know it has travelled for millions of years only to dissolve in sunlight still feels sacred. As 3S/TLAS changes, its orbit shifts subtly. The gases it releases push back against gravity's pull, altering its speed, nudging its path. These adjustments, though minute, can ripple across space. A small outburst now might determine where the comet will drift for centuries to come. You think of how small changes in your own life, a choice, a word, a moment of clarity, can redirect an entire future. Like the comet, you are shaped not by stillness, but by each encounter with light. Astronomers describe the process clinically. The nucleus is fragmenting. But you, sitting in the quiet of night, feel something more tender. The breaking is not failure, it is transformation made visible. The comet's brilliance, the shimmering tail that delights the sky, comes only because its body is unraveling. To shine, it must release what it once held tight. You imagine standing on its surface, though there is no true ground there, only porous ice and ancient dust. Beneath your feet, gas escapes in bursts, forming columns that twist and vanish. The sun is a distant blaze, and every grain of material that lifts away becomes part of the comet's luminous veil. The airless silence is total, yet you can almost feel the hum of energy, the faint vibration of molecules fleeing toward light. Change here is not noise, it is music beyond sound. Back on Earth, telescopes capture a sudden brightening, an outburst that multiplies its glow by several magnitudes. For a few days, 3I/TLAS burns like a promise, visible even to small instruments, an emerald fire against the black. Then the brightness fades again. Dust disperses. The core dimensions. What remains is a blurred memory, a ghost of its earlier brilliance. You realize that even in fading there is grace, the calm acceptance of return to quiet. The astronomers write their reports, their numbers steady, their graphs exact. But behind those lines of data lies something the instruments cannot record. The emotion of watching a celestial being evolve before your eyes. The slow truth of the universe is that everything is in motion. Everything is becoming something else. Even the most ancient ice cannot resist the song of heat. And you too are part of that same law. Your thoughts melt, your beliefs sublimate, your identity reshapes with every touch of light and time. You are never fixed. You are always quietly changing your face. The comet drifts onward now, lighter than before. Its fragments trail behind like the memory of breath. The gases that once formed its core disperse into interplanetary space where sunlight and magnetic fields will carry them far away. Some of those atoms may join other clouds, other comets, other worlds. Change does not erase, it reweaves. You sit with that thought as if it were a lullaby. To change is to continue. To lose shape is to find motion. To dissolve is to join the greater harmony. The last glimmer of 3I/TLAS fades from the telescope's eye. Yet its chemistry remains written in spectra, its trajectory in equations, its story in human wonder. You sense that it has not vanished, only dispersed, like a song that no longer needs a single voice to be heard. And somewhere deep within that thought, another question begins to form, quiet, glowing, at the edges of your mind. What does wonder itself mean? Is it the act of watching, or the feeling of being changed by what you see? The answer waits softly in the next drift of thought, in the science of wonder. You sit in quiet darkness, letting the comet's image fade from your mind, its light, its changing face, and its drifting fragments all dissolve into a single word that hums softly in your chest. Wonder. For a moment you do not reach for answers, you simply breathe. You let your mind rest in the space between knowing and not knowing. Science often begins here, in that pause, in the stillness before the question takes shape. The astronomers who watched 3I/TLAS change were not chasing certainty, they were chasing meaning. Each measurement, each spectrum, each calculation was a way of saying, I see you, and I wish to understand you. But understanding, you realize, is not always about possession. Sometimes it is about reverence. You think of the word wonder, how it stretches between curiosity and humility. To wonder is to admit that you are small and yet capable of perceiving the vast. When scientists observe the universe, they are not closing its mysteries. They are opening them wider. Each discovery does not end a story, it begins another. Like a comet's path, science curves endlessly forward, never looping back to completion. 3I/TLAS reminded humanity of that truth. It came from beyond the solar system, beyond even the reach of memory. It was the third known interstellar object to visit, after Oumuamua and Borisov. Yet unlike them, it behaved in ways that defied prediction. It brightened too soon, then dimmed too fast. It shifted its structure, its orbit, its brightness. Each surprise was not a frustration, but an invitation, an open door into the unknown. You imagine the astronomers watching from mountain observatories, wrapped in coats against the cold, their faces lit by computer screens and starlight. For them, wonder is not a fleeting feeling, it is a discipline. It takes patience to gaze through a telescope, to wait for data that may take hours to appear. It takes humility to accept that much of the universe will never reveal itself completely. And it takes love, a quiet, steady love, to keep looking anyway. You too can practice that kind of seeing. You do not need a telescope, you only need attention, the willingness to notice. The night sky is not silent. It speaks in a language older than sound. The rustle of wind through trees is the whisper of the atmosphere the earth still holds. The faint shimmer of stars is ancient light, photons that have travelled for millions of years just to reach your eyes. To look up is to touch the edge of time. The science of wonder begins with awareness. You breathe, you notice the rhythm of your pulse, the warmth of your skin, the tiny electric currents that move through your nerves. All of it, down to the atoms in your cells, shares kinship with the comet you watched. Hydrogen from the Big Bang, carbon from old stars, oxygen from long-vanished nebulae. These same elements shaped you. When you wonder at the universe, you are also wondering at yourself. Science does not replace mystery, it refines it. Each discovery is like polishing a lens. The image becomes clearer, but the view grows larger too. When astronomers measure the speed of 3I/TLAS or analyze its spectra, they do not diminish its beauty. They translate it into another form, a language of patterns and numbers that still holds emotion. Behind every equation is a feeling, awe, curiosity, tenderness. Even mathematics can be an act of devotion. You recall reading that the human brain releases dopamine when it encounters something new and beautiful. The biological echo of curiosity, that gentle rush, that widening of awareness, is evolution's way of saying, keep exploring. Wonder, then, is not just poetic, it is physical. Your body is built to marvel, your senses, your neurons, your imagination are tuned for discovery. You were made to be amazed. The scientists who tracked 3A TLAS did not find all the answers they hoped for. Its disintegration left questions unresolved, or its origins uncertain, its structure partly guessed, but that too is part of wonder's science. The unanswered question is not failure, it is fuel. It keeps the imagination turning, keeps the story alive. You think of how often in your own life you have sought closure, a final explanation, a complete understanding. Yet perhaps, like a comet, you are not meant to loop back to certainty. You are meant to keep moving, to evolve through curiosity. The universe does not demand comprehension, it invites participation. Outside your window, the night deepens. You picture the comet somewhere beyond the reach of instruments now, its fragments fading into space. It no longer burns, no longer glows, yet its presence lingers. In data, in memory, in wonder. Even unseen, it continues to inspire. You realize that wonder does not depend on sight, it depends on openness. You rest your thoughts there, letting them drift like particles of dust through sunlight. Science and mystery do not compete, they complete each other. To study is to love, to wonder is to remember that love. The next chapter of this journey will ask how that love, that act of seeing, becomes understanding. How light itself, split into colour, begins to speak. For every question you hold tonight, the answer waits in the spectrum of dawn. You imagine a beam of light travelling through the emptiness of space, silent, unbroken, pure. It leaves a star, crosses the void, and finally meets a mirror, a lens, a telescope. And then, through one more simple trick of physics, it reveals its secret. When light is spread into its colours, it begins to speak. This is the language of spectra, the poetry of atoms made visible. Every colour, every faint line in the rainbow of starlight carries a signature. Hydrogen whispers in red and violet. Oxygen glows in green. Carbon, sodium, iron at each element leaves its own pattern of brightness and shadow. To a scientist, these lines are letters. To you, they are music turned to colour. When astronomers looked at the faint light reflected from 3I/ATLAS, they turned to this language for guidance. The comet's light was not its own. It was sunlight, scattered and altered by dust and gas. Yet even in reflection, the spectrum spoke. Through it, scientists could read what the comet was made of, what frozen molecules lay within its ancient heart. You picture the process, light passing through a prism or a diffraction grating, bending into a soft arc of hues. Sensors record that light, measuring tiny differences in wavelength. A graph appears, peaks and dips across a field of colour. It doesn't look like art, but it is. Each pattern tells of bonds and atoms, of temperature and distance, of age and origin. It is as if the universe left a diary written in invisible ink, and science found the light to read it. For 3I/TLAS, the pages revealed strangeness. Ratios of carbon to oxygen that did not match any known comet of our solar system. Molecules that hinted at formation in colder, more distant regions, perhaps around a smaller, dimmer star. Its chemistry carried the scent of another sky. To study it was to glimpse an alien past, to see how other worlds once built their ices and gases. You think of how language works, how meaning hides in pattern and rhythm. The same is true of spectra. It is not just about identifying what elements exist, but how they interact. When two atoms meet, they share energy, they emit light. Those emissions form lines in the spectrum. Each one is a conversation between particles, frozen in colour. And when you read that colour, you are eavesdropping on the oldest conversations in existence. In a way, you realise the universe is constantly seeking. It talks in radiation, in wavelength, in the hum of background noise that fills every corner of space. Most of the time, you don't hear it, not with your ears at least. But when instruments translate that hum into light or data, the voice of the cosmos becomes clear. The science of spectroscopy is simply learning how to listen. You remember a childhood memory, sunlight through a window breaking into rainbows on the floor. You followed the shifting colours, tracing them with your hand. Even then, before you knew about wavelengths or refraction, something inside you understood that light was more than brightness. It was information, something alive. And you see that the same principle connects your memory to the comet, your eyes to the stars, The prism that splits sunlight is not different from the one astronomers use, only the scale has changed. Spectroscopy, you learn, began centuries ago with simple glass and flame. Scientists burned salts and watched them glow, green for copper, crimson for lithium. Those colours became clues. Later, with prisms and lenses, they learned that stars and comets too carried these same spectral fingerprints. It was a revelation. Matter here on Earth was the same as matter out there. The barrier between heaven and home dissolved. So when scientists point their instruments toward 3I/ATLAS, they are not just studying a comet, they are listening for kinship. They are comparing the language of its light to our own. The differences tell of distance, of a birth under another sun, another chemistry, another ancient cloud of gas and dust. Yet the similarities remind us that all creation is made from the same alphabet of atoms. You imagine the astronomers again, patient, methodical, tracing peaks on a screen, their eyes tired but intent. To them, the faintest spectral line is a story. It may take hours to extract, days to interpret, years to understand, but each one matters. Each one says, this is real, this is what the universe made. And still, there is mystery. Some lines in 3I/ATLAS's spectrum do not match known molecules. Some regions remain blank, waiting for discovery. Science does not rush to fill these spaces with guesses. It lets them breathe. It waits. Wonder too needs silence between notes. You think of colour differently now, not as decoration, but as message. Every hue you see, in the sky, in a flame, in a leaf, is the echo of interaction. Light, shaped by matter. The blue of Earth's atmosphere is scattering. The red of sunset is distance. The green of auroras is oxygen made to glow. Everything around you is a visible equation, solved by your eyes, felt by your heart. The comet, millions of kilometers away, continues to scatter sunlight. Its tail lengthens, its spectrum widens. The lines tell of methane, ammonia, cyanide, and water ice, ingredients that once formed planets and oceans. You remember that the same chemistry runs in your blood, in the air you breathe. The light of 3I/ATLAS, decoded by science, becomes a mirror for your own composition. You are reading yourself through a comet's glow. At times, the data feels abstract, too distant to touch, but then you recall, every photon captured by a telescope is a traveller. It left the comet, crossed space, and arrived here. Some of those photons may have struck the sensors of an observatory at dawn, while someone stood nearby sipping coffee, unaware of the miracle of light landing at their feet. The cosmos, you realize, reaches us in quiet, ordinary ways. And perhaps that is the true beauty of the spectrum. It reminds you that meaning can be hidden in what seems simple. A band of colour, a faint line on a graph, a whisper of brightness in the dark. Through them, the universe reveals its structure, not with drama, but with patience. Each colour, each number, each photon carries intention, the slow handwriting of creation itself. You sit back, eyes closed, and imagine the rainbow of 3I/ATLAS unfolding in the darkness. The comet no longer seems silent. It speaks in wavelengths, in chemical notes, in the harmony of elements exchanging energy across impossible distances. You can almost hear it, a hum at the edge of hearing, a spectrum turned into song. And as you listen, a thought begins to glow at the edge of your awareness. If this light tells of another sun, what world might that sun have warmed? What story does the messenger carry from that faraway sky? If 3I/ATLAS came from another star, what story does it bring? You picture another solar system, long gone cold, a sun that once burned brightly and planets that once carried oceans, mountains, and maybe even something that looked up at the sky in wonder. Perhaps it was there that this comet began its journey, torn away by gravity's patient hand. And now, after ages that no human measure can capture, it has crossed the silent gulfs between stars to arrive here, in the faint blue light of our own sun. Astronomers have watched it with awe, not because it is large or bright, but because of what it means. It does not belong to us. Its orbit, its speed, its chemistry all whisper the same secret. This visitor was born beneath another sky. When telescopes trace its motion, they find it moves too quickly to be captured, too straight to loop around. It comes, it glows, and it goes, a messenger carrying the memory of a forgotten system. You imagine the moment of its birth. Maybe it began in the outskirts of a distant protoplanetary disk, a lump of ice and dust that never became a planet, circled its parent star for billions of years, unseen, till something massive brushed past, a wandering planet, a passing neighbour, and gravity flung it free. From that instant it became homeless, a traveller of interstellar space. It drifted in total darkness, past nebulae and empty light years, for longer than Earth has existed. Now, as it glides past our sun, we can read traces of that journey. The spectrum of its light reveals molecules that are older than the solar system itself, cyanides, hydrocarbons, frozen water that has never melted. These are relics of cosmic chemistry, clues to the universality of life's ingredients. Every line in the spectrum is a syllable in the comet's story, every flicker a word in the language of distance. Scientists study it, yes, but beneath the data there is emotion, the quiet realization that we are not alone in material or memory. The dust that coats our planets, the carbon that fuels our lives, and the ices within 3I/ATLAS may have been forged in similar furnaces, scattered by ancient explosions, drawn together again by the same laws that shape galaxies. The visitor reminds us that everything is connected by physics and by the longing to persist. In a sense, this comet is an ambassador, not from another civilization, but from another creation. It tells us that what happens there, wherever there is, happens here too. It tells us that star systems are not sealed worlds. They trade their matter. They send fragments of themselves into eternity. And sometimes, by chance, one of those fragments comes close enough to be seen. You think about what that means for Earth. Every grain of interstellar dust that falls through our atmosphere, every faint comet that crosses our sky, adds to the story of how we came to be. 3I/ATLAS is another verse in that story, an echo of another dawn. It is as if the universe is reminding us that creation never truly ends. It just keeps moving, sharing its seeds across the void. For the astronomers, it is a rare chance to study something pure. Most comets in our solar system have been baked and battered by repeated passes near the Sun. But an interstellar comet like 3/ATLAS is pristine, untouched since its formation. It carries within it the chemical handwriting of another sun's nursery. By studying its spectrum, scientists glimpse the diversity of cosmic chemistry, how stars, wherever they form, craft similar patterns from the same elemental alphabet. Some even imagine that comets like this might one day explain life's persistence. The theory of panspermia, that life's building blocks travel between worlds, becomes less abstract when you watch a comet cross from one system to another. Could 3I/ATLAS, or something like it, once have carried amino acids across the dark? Could it have brushed against a young planet and left behind the first spark of complexity? No one can say for certain. But the possibility feels alive in the silence of its path. As the comet nears the sun, its surface begins to wake. Ice turns to vapour, gas jets outward, dust scatters like memory. The tail glows faintly, a veil of blue and white stretching millions of kilometres behind. It is beautiful but temporary. Soon it will be gone, leaving behind only numbers, images, and a lingering sense of awe. Yet in those moments of observation, something profound happens. A meeting between two systems, two ages, two forms of light. You imagine for a heartbeat that somewhere out there in this direction 3I/ATLAS came from, another civilization might once have looked at their own comets, wondered about the cosmos, and dreamed of the beyond. Perhaps their questions drifted outward, unanswered, until one small icy traveller carried their legacy here. And now, standing under our sky, you are part of the answer. When the comet fades from view, the data will remain. Its orbit will be traced in software, its spectrum archived, its story written into papers and models, but its meaning will continue to hum quietly in human thought. We will look up years from now and remember that once a messenger from another sun passed close enough for us to notice. It didn't stop, it didn't stay, but it reminded us that the space between stars is not empty. It is filled with connections, slow and silent, waiting to be seen. You close your eyes and think of its journey, a line drawn through the galaxy, across light years, through epochs. It began with a loss, a separation from its home, and it ends not with an arrival, but with another departure. Yet in that passage it touched us. It changed nothing in the cosmos, and everything in our understanding. For a brief moment, a comet from another sun crossed our sky, carrying not answers, but the comfort of shared existence. And then, just as quietly, it was gone. Inside its frozen center, molecules remember the heat of creation. Carbon, oxygen, water. A pattern older than DNA. You realize the comet is not just an object, but a record, and memory in the universe is made of matter. Deep within the nucleus of 3I/ATLAS lies something that has not changed in billions of years. Every grain of dust and shard of ice inside it is a page from a time before planets had names. These atoms, locked in crystalline stillness, have drifted through eras when galaxies collided, stars were born and others died in silence. And yet the comet carries them, unaltered, a vault of the ancient universe drifting between suns. When astronomers point their instruments at it, they are not just studying a comet, they are reading a memory, one not written in ink, but in ratios of elements and isotopes. In laboratories on Earth, scientists capture light reflected from the comet's coma and split it into spectra. From that color pattern, they reconstruct its chemistry: methane, carbon monoxide, cyanides, and complex organics. These are the same molecules that once filled the nebula that became our own sun. It is as if the comet remembers the recipe of creation itself. You think of memory as something that happens in minds, in neurons and stories. But here, in 3I/ATLAS, memory is frozen in ice. The hydrogen atoms in its water formed when the universe was minutes old. The carbon in its dust came from the death throes of ancient stars. Each fragment carries an unbroken chain of events that stretch back to the Big Bang. Nothing in its body is young. Even its semblance is ancient. Scientists often describe comets as time capsules, but the phrase feels too small. A capsule is a container, something deliberately made. This is not a machine. It is a coincidence of gravity and temperature, a natural archive of the universe's unfolding. And yet its existence suggests something deliberate about nature itself, the tendency to keep records, to store the past within the present. As 3I/ATLAS nears the Sun, parts of that archive begin to vaporize. Gases that have been trapped for eons finally escape into light. Telescopes catch those exhalations, analyzing what they can before it's gone forever. It's a strange paradox. To learn what's inside, the comet must lose itself. Every observation is an act of erasure. The more we know, the less remains. You imagine standing close to it, impossibly close, watching jets of vapor burst from cracks in its crust. Each release is like a whisper of memory escaping into space. You can almost hear the sigh of molecules returning to the warmth they once knew. The tale that forms behind the comet becomes a trail of forgetting and remembering, written across the void in shimmering dust. Some astronomers wonder what these interstellar comets can tell us about the diversity of other systems. Are all suns born alike? Do all comets hold the same ratios of hydrogen to deuterium, carbon to nitrogen? Or does each system craft its own distinct signature? 3I/ATLAS offers clues, but not answers. Its chemistry both mirrors and differs from ours, familiar yet not identical. It tells us that the universe remembers patterns but never repeats them exactly. Every world, every comet is a variation on a theme. That too is a kind of memory, not a fixed one, but evolving. The universe does not cling to the past, it recreates it in infinite forms. The same atoms that once lived in a star now drift in a comet, and one day may fall into a planet's atmosphere, into soil, into life. Memory in this sense is not about keeping, it is about transforming. When you think of it that way, you begin to see 3I/ATLAS not as a foreign visitor, but as a relative, a distant cousin in the great family of matter. Its atoms and ours are not separate stories, they are chapters in the same cosmic autobiography. You breathe oxygen that once belonged to a star. You are built from dust that once wandered the same interstellar roads this comet travelled. To look at 3I/ATLAS is to look at your own history stretched across time and space. The more scientists learn about it, the more they speak of memory in metaphorical tones. One researcher calls it the archive of frozen light. Another says it remembers the temperature of its birth. These are poetic ways of saying something profoundly physical, that matter keeps records of what it has experienced. The ratios of isotopes in the comet's ice reveal the temperature of its formation. The composition of its carbon tells how long it lingered near its star before being flung away. The comet's path remembers the violence that ejected it into the void. Every atom is evidence, every orbit a memory trace. You think of human memory, fragile, partial, fading. The universe's memory is slower but surer. It does not recall in emotions but in structure. Ice holds the coldness of its origin. Dust retains the echoes of radiation. Gravity keeps the shape of long-ago motions. To the cosmos, remembering is the same as continuing to exist. As you imagine the comet's long journey, you begin to sense a deeper idea. Memory may not just be something that happens in time. It may be what time itself is. The unfolding of events, the persistence of cause into effect, is one vast act of remembering. In that view, the comet is not carrying memories through time. It is the memory of time preserved in orbit, shape, and motion. The scientists will continue their work, gathering light, analyzing, comparing. Eventually, 3S/8LAS will fade from view, leaving behind datasets and models. But something will remain that cannot be measured. The feeling that even in cold, lifeless matter, there exists continuity, the echo of the beginning. The comet is not alive, and yet it behaves like something that remembers where it came from. You imagine one of its fragments, broken loose and wandering alone through space. It might drift for millions of years, unseen, untouched, until it encounters another system. Perhaps there it will fall toward another sun, releasing once again the vapor of its ancient chemistry. Another civilization might study it, marveling at its strangeness, wondering where it came from, and in that moment the memory will continue, passed from one observer to another, one world to the next. In the end, you understand 3I/A/TLAS does not just travel through space, it travels through time, carrying within it the structure of everything that was. To look at it is to look backward, not just at another star, but at the first fire that ever burned. Its frozen heart is not empty. It is filled with the quiet persistence of memory itself, the universe remembering that it once knew light. It starts slowly, almost imperceptibly. A faint distortion in the comet's glow. What was once a single solid body begins to flicker unevenly. Astronomers notice first. The light curve changes, brightness rising and falling in irregular waves. The data suggests stress, pressure, or internal cracking. In the cold darkness between planets, something inside 3I/ATLAS is coming undone. You picture it not as a violent shattering, but as a deep, slow release. The ice within, once held tightly for millions of years, warms as it nears the sun. Volatile gases trapped in tiny pockets push outward, searching for escape. Each jet of vapor widens a fissure, turning cracks into chasms. The comet's structure, once whole, becomes a patchwork of fragments, held together only by the gentlest threads of gravity. No sound reaches across space, but if it did, you imagine the noise, a low, sighing crack, the sound of ancient ice surrendering. Pieces drift away, tumbling lazily at first, then scattering into individual orbits. The comet is no longer one traveler, but many. Each fragment continues forward, a chorus of remnants moving through sunlight. For scientists watching from Earth, this is both a loss and a revelation. Disintegration offers data that stability cannot. As the comet breaks apart, it reveals layers that were hidden deep within, layers untouched since before planets formed. The fragments expose the purest materials, the first ices of the early galaxy. Every crumble is a confession. The comet, in breaking, tells the truth of its construction. You imagine this process as both tragic and beautiful. The idea of loss comes easily, a once whole traveler now dissolving. But another perspective appears. What if this is the natural continuation of its purpose? To wander, to transform, to release what it carries. Perhaps the comet's journey was never about surviving intact. Perhaps it was about sharing what it remembered, scattering its archives into the cosmos. In the bright glare of the sun, the pieces glitter. Some reflect more light than others. Some evaporate completely, leaving only dust and ionized trails. The coma, the cloud of gas surrounding the comet, expands dramatically, glowing with a faint ghostly blue. From far away it looks as though 3I/TLAS has grown, not diminished. Its body shrinks, but its presence fills more of space. There is something profoundly human in this image, the idea that we too become larger in what we leave behind. The comet's fragments will drift on for eons, crossing paths with planets, starlight and magnetic winds. They will be forgotten as individual pieces, yet they will continue to exist in radiation, in dust, in data, in dreams. What once was one becomes many. The word disintegration sounds final, but it isn't. In physics, destruction is only transformation. Matter cannot vanish, it merely changes form. The fragments of 3I/ATLAS are not gone. They are redistributed, their orbits rewritten. In the language of the universe, this moment is not an ending. It is a diffusion, a widening of being. Astronomers track the breakup using light curves, telescopic images, and orbital models. Each piece gains a name, a number, a trajectory. The data resembles music, notes on a sheet describing motion and decay. The scientists listen with equations, composing the melody of dissolution. The comet, once a silent traveller, now plays its final movement across the solar wind. You feel the rhythm of it, slow, grand, inevitable. Each piece that breaks away seems to echo a truth about existence, that nothing endures unchanged, and that change itself is the only lasting structure. The comet's collapse mirrors galaxies colliding, stars dying, even thoughts fading. All things dissolve, but the pattern continues. The act of falling apart is woven into the universe's design. In its earliest days, 3I/ATLAS was formed from the debris of other destructions, shattered stars, dispersed nebulae, recycled dust. It began as fragments long before it broke apart. The cycle turns again, and now it returns to that same state. You realize that in a cosmic sense, it is not dying. It is returning home. Some of its fragments will travel alone, cooling slowly in the dark between stars. Others will collide, merging briefly before scattering again. A few may fall into the gravitational reach of distant worlds, burning up in their atmospheres or joining their soils. In each possibility, the comet continues to participate in creation, no longer as one traveller, but as countless seeds of new stories. You picture the faint glow it leaves behind, a stream of light stretching across space, like a trail of forgotten thoughts. Somewhere within that trail, a single particle of dust may one day drift into the path of Earth. It will enter our atmosphere, flash brightly for a heartbeat, and vanish, a shooting star carrying within it the chemistry of another sun. Someone might look up at that flash, unaware that they are witnessing the memory of 3I/ATLAS returning to light. There is peace in the thought that disintegration can also mean release. The comet has travelled far beyond the systems that birthed it. Its long cold voyage has ended not in silence but in radiance. Even as it comes apart, it shares its story, a quiet surrender that enriches everything around it. What it loses in structure, it gains in influence. Its fragments are like scattered notes that will continue to play long after the song has ended. Scientists will write papers, graphs, and theories about this moment. They will calculate the stress thresholds, the vapor pressures, the spin rates that tore the comet apart. But none of those numbers will capture what you feel when you imagine it, that deep, tender recognition of impermanence. To see 3I/ATLAS dissolve is to see yourself reflected, a reminder that all existence is motion, all matter is memory, and all endings are transitions. You close your eyes and picture the pieces drifting away from one another, their distances growing silently with every hour. The sunlight that touches them takes minutes to travel, but the meaning of their motion seems timeless. There is beauty in the space between them, the invisible threads of trajectory that connect what was once whole. The comet, now spread thin across millions of kilometers, becomes not a body but a constellation of memory. Even as its light fades, you can sense the persistence behind it, the way dust lingers, the way patterns endure. The disintegration of 3I/ATLAS is not erasure. It is revelation. In breaking apart, it shows us that everything the universe creates, it also recreates. Matter never leaves the story, it simply changes how it is told. And as you think of that trail of fading light still glowing faintly beyond vision, you understand that this is not the end of the comet's journey. It is the beginning of many. Each fragment will carry the same memory forward into new regions, new orbits, new darkness. The universe once again remembers itself and waits for what those fragments will become next. The moment of breaking has passed. What remains now is movement, quiet, unhurried, eternal. The fragments of 3I/TLAS, once bound together in a single frozen body, begin their long, separate journeys. There are hundreds, perhaps thousands of them, each following a slightly different path through space. Some are no larger than grains of sand, others could fill a small room. Together they form a river of motion, a diffuse shimmering current flowing through the black. In the vacuum they make no sound, yet you can almost feel the rhythm of their travel. The soft pulse of trajectories written by the laws of gravity. Each fragment moves according to its own inherited momentum, a memory of the force that once held it. That invisible physics still shapes them, guiding them through an unending sea of silence. You imagine what it must be like to be one of them, a shard of ancient ice and rock spinning slowly, untouched for millions of years. The stars wheel around you, the sun grows smaller and colder. There is no up or down, only directionless drift. The heat from the comet's last approach fades away, and with it, the last whispers of its coma, the glowing gas cloud that once made it beautiful. What remains now is bare surface, crystallized dust, frozen molecules that sleep deeper than time. Some fragments stay near each other for a while, their paths still entwined. You picture them as companions, traveling side by side before the vast geometry of gravity pulls them apart. Over decades, centuries, millennia, they diverge. One fragment may be drawn toward the faint pull of Jupiter. Another may slip past Neptune, escaping the solar system entirely. Each one becomes its own comet, its own traveler, carrying the same story rewritten in motion. Scientists call these remnants debris trails, and they can persist long after the parent body is gone. They trace delicate filaments across the sky, invisible most of the time, but revealed when sunlight or magnetic winds touch them. Some may pass close enough to Earth to create meteor showers, brief, luminous reminders of a disintegrated visitor. The dust enters our atmosphere, glows for a heartbeat, and then disappears. The comet's memory burns bright enough to touch human eyes, if only for an instant. In this way, 3I/TLAS continues to exist, not as a whole, but as a presence scattered across distances too vast to measure. Its story becomes one of endurance. The comet's original purpose, if there ever was one, dissolves into the quiet persistence of physics. Even fragments obey the same laws: inertia, gravity, the curve of motion. The universe gives no special meaning, but you do. You see in this endless drifting something that feels like faith, that even the smallest pieces matter, that nothing is ever truly lost. Somewhere far from here, one of those fragments might cross into interstellar space. It will pass beyond the sun's influence, into the territory between stars. There, it will float for millions of years, unseen and untouched, a grain of another system's memory. Perhaps it will someday be pulled into a new star's birth cloud, becoming part of a planet, or a moon, or another comet entirely. The matter that once made up 3I/TLAS will live again, transformed but continuous. You think about how all things follow this pattern, the recycling of matter, the migration of memory. Every atom in your body once belonged to something else, an old star, a dying sun, a meteor, a leaf. You and the comet share the same inheritance, fragments of the universe rearranged. There's comfort in that symmetry. It means that even if everything falls apart, it still continues in another form. From a telescope's view, the fragments eventually fade from detection. They grow too faint, too small, too distant to measure. The instruments see only darkness, yet astronomers know they are still out there, tracing the mathematics of their last acceleration. The equations say they will keep going, forever or close enough to it. In the language of physics, that word forever has no end. It is simply motion, without return. You let that image rest in your mind. Countless particles gliding through space, invisible but real, each one carrying within it a story of heat, pressure, and release. The fragments become symbols of everything that endures quietly. The small continuations that never make headlines, the hidden persistence of life and matter. If you could ride alongside one, you would see light bending gently across its surface. No atmosphere, no sound, no weight. Just a crystal of dust illuminated by distant stars. Time loses meaning here. There is no beginning, no ending, only existence stretched into infinity. Every second feels like a century. Every motion feels like stillness. In this still drift, there's something peaceful, almost sacred. The comet, in its brokenness, has entered a new kind of grace. It no longer fights against gravity or sunlight. It simply follows. The act of falling apart has become an act of surrender. And in surrender, it finds balance. The fragments do not seek destinations, they only continue. That, perhaps, is the universe's deepest rhythm. Persistence without purpose, movement without conclusion. You imagine one fragment brushing past a planet's magnetic field, charged particles whispering across its surface. Another may collide gently with interplanetary dust, losing a little of itself each century. Still others may drift undisturbed through cosmic dark, waiting for light that may never reach them. Each fate is different, but all are part of the same unfolding, the quiet expansion of the comet's existence into the fabric of space. Even as the comet disappears from observation, its influence lingers in human thought. Scientists will study the data for decades. Poets will imagine what it means for something to come from another star and leave again, changed. You too are part of that remembering. As you picture those fragments fading into night, you realize that stories, like matter, scatter, but never vanish. The comet's disintegration was not its ending, it was its multiplication. Each piece carries the same truth, the same origin, the same trace of the first fire that made it. 3I/TLAS has become a constellation of continuation, proof that even in the emptiest places, motion endures. You follow one fragment in your mind's eye until it becomes a single speck of faint light, then less than that, only an idea of light. It moves onward, beyond what you can imagine, into silence so complete it feels infinite. And there, somewhere past the last glow of our sun, it keeps going, quietly teaching that even in pieces, the journey never ends. You sit with your notebook open, the pages filled with lines and symbols that seem to hum softly in the dim light. Numbers curve into shapes and equations begin to breathe. The room feels still, but inside the stillness, there's motion. An invisible current that carries meaning from one side of the page to the other. You draw a spiral, not of art, but of orbit, and imagine 3I/TLAS following it across the dark. The mathematics that describe its motion are elegant, elliptical, parabolic, bound and unbound, yet somewhere between calculation and reality, a small difference remains. That difference is wonder. Every variable in physics holds a story, time that stretches, distance that bends, mass that becomes energy and back again. You realize that the universe is written in equations not to hide its truth, but to let it be spoken in infinite languages. A formula for gravity becomes a whisper about connection. A constant of motion becomes a promise that balance exists even in the vastest void. You breathe in the rhythm of these truths, the way a poet listens to syllables, and feel their calm precision sink into your thoughts. The orbit of a comet can be described perfectly, and yet no equation feels the chill of its dust or the glow of its coma. Mathematics gives you the shape of its path, but not the awe of seeing it sweep through your sky. You sense that wonder is not what math solves, it's what remains unsolved. Like a pause between two notes, it's the sourness that gives the pattern meaning. You look again at the curve that 3I/TLAS traces across the solar system. It is not just a line of motion, it's a question drawn in light. Why this angle? Why this speed? Why now? The parameters are measurable, but the choice of existence, the why, is beyond any formula. That mystery comforts you. It means there will always be something left to explore. You realize that science, at its heart, is not certainty but curiosity made patient. Mathematics becomes a kind of meditation. You count, you calculate, you let logic carry you like waves carrying driftwood. You see patterns that repeat, golden ratios in shells, spirals in galaxies, oscillations in the orbit of a comet. The universe is recursive, endlessly echoing its own beauty. Somewhere hidden beneath symbols is a truth that everything connects. Energy to matter, motion to stillness, question to answer. You find peace in that symmetry, and yet when you consider 3I/ATLAS, you feel the gentle rupture of that peace, a comet that doesn't belong, that follows no closed loop. It's a visitor from beyond the sun's dominion, and its trajectory refuses repetition. It doesn't circle back, it continues on. Your pencil hesitates. You write the word infinite and underline it twice. Infinity isn't a number, you realize. It's the idea that something can keep going and never become complete. Like thought itself, you start to think of yourself as part of the same equation. One small term in the universe's unfolding sum. Your heartbeat is time measured in pulses. Your breath is a fraction of the atmosphere shared by stars. The laws that govern comets also govern you. Momentum, energy, decay. And just as 3I/TLAS breaks free from a solar system's pull, perhaps wonder is what lets the human mind escape the boundaries of understanding, to imagine what lies outside its orbit. Every discovery begins as a calculation, but every revelation begins as an emotion. The difference between them is what makes you human. Numbers can explain what happens, but not why you care. You realize that the true mathematics of wondering is emotional arithmetic, adding questions, subtracting fear, dividing time into moments of clarity, multiplying awe. You feel how thought and feeling converge, how curiosity becomes a constant. Outside your window, the night sky feels like an equation too, countless points of light arranged in quiet precision. And somewhere, far beyond sight, 3I/ATLAS continues on its path, a variable moving through the unknown. You picture its position as a coordinate in the vast geometry of the universe. Even if no telescope ever finds it again, its line has already been drawn, a permanent addition to the cosmic graph. You close your notebook. The equations fade into memory, but the peace they brought remains. In every rule there is room for mystery. In every proof, a place for poetry. The universe does not require you to solve it, only to listen, to trace its curves with patience, to love its precision, even when it breaks its own patterns. You let your eyes rest, thinking of all the equations you'll never finish, all the infinities you'll never measure. Somewhere beyond, 3I/TLAS drifts through a sky that no longer belongs to the sun, carrying with it a pattern too complex to ever be complete. You smile at the thought that perfection isn't the end of wondering, it's the beginning of peace, and in the silence that follows, you sense the pause before understanding, a quiet waiting, leading gently into the next stillness. The observatory is dark now, the red lights are dimmed, screens gone cold. Only the faint hum of cooling systems remains, and even that feels like it's whispering. You stand near the window where the last trace of the comet once shimmered on your retinas. It's gone, far past where instruments can follow. The sky looks empty again, but you know it isn't. It's simply quiet, the kind of quiet that holds meaning rather than absence. In this pause, the world feels wider. You sense that discovery isn't a constant blaze, it's a rhythm, the alternating pulse of knowing and not knowing. You've spent weeks surrounded by numbers and signals, equations and interpretations, the hum of telescopes tracking a traveller from beyond the sun. Now, as the data slows to a stop, what's left is reflection. Science breathes out after every deep inhale of discovery. You take off your gloves, feeling the warmth return to your fingers. The night has cooled, and the stars above seem softer, less like points of data and more like companions in the stillness. Somewhere beyond all this, 3I/ATLAS continues to move, no longer watched, no longer measured. It doesn't need to be observed to exist. Its silence is part of its truth. You think about how every experiment ends not with an answer, but with a question turned inward. What does it mean to know? What does it mean to wonder? The quiet after discovery feels like the soft space between heartbeats, necessary, natural, human. You remember that every telescope has a limit, every equation a range, every mind a horizon. Beyond each is stillness, and beyond stillness, renewal. You sit down by the console and open your journal. The pages are filled with calculations, sketches of the comet's path, temperature readings, chemical estimates. But tonight, you write something different. You write about the feeling of watching something vanish, how it teaches you to appreciate the moment before it does, you realize that science is as much about patience as precision. The spaces between results are what give meaning to the results themselves. The quiet becomes almost tangible, as if the room itself is waiting. You can hear the wind outside the dome, brushing against metal and glass. It reminds you that even silence moves. Perhaps the universe too takes pauses between acts of creation, cosmic intermissions that allow the stars to breathe. You imagine galaxies resting between collisions, gravity holding its breath before shaping something new. This in-between feels sacred. It's not the end of discovery, but its echo. In that echo you find understanding that can't be graphed, a recognition that knowledge is cyclical, not linear. You remember your first night here? The thrill of aligning lenses, the hum of motors, the sudden appearance of light from an object no one had seen before. Now, there's no movement left to track, and yet, you feel the same awe, quieter, deeper, more complete. You stand again and look up. The stars are still there, indifferent to human excitement or fatigue. They watch silently, burning with their own steady logic. You wonder if they too experience their own kind of stillness. Nuclear hearts that pulse with calm inevitability. The more you think, the more you understand that silence isn't the opposite of science. It's its foundation. Without pause, there's no clarity. Without stillness, no revelation can settle into meaning. You think of 3I/ATLAS slipping now into interstellar night beyond the reach of any voice or machine. Its motion continues in perfect obedience to physics, but its purpose remains beyond words. Maybe that's what the universe is always trying to show, that knowing everything isn't the goal. Feeling something about what you know is. That's why the quiet matters. It lets the understanding become personal. In the corner of the lab, a single monitor flickers with the last line of recorded data, a timestamp, a coordinate, a line of code that marks the comet's final detectable trace. You copy it down not because you need it, but because it feels like closure. The machine hum fades and the moment becomes purely human. You close your notebook and exhale. The silence deepens until it feels almost cosmic, not emptiness, but fullness too vast for sound. You close your eyes and listen to the space inside your thoughts, to the echo that connects your breath to the stars. For the first time in weeks, you allow yourself to rest. Discovery is a heartbeat. Wonder is its rhythm. Both require stillness to keep time. When you open your eyes again, dawn is approaching. The first hint of light creeps over the horizon, washing the observatory in pale silver. The universe hasn't changed overnight, and yet somehow you have. You feel lighter, as if silence itself has explained something words could not. You smile, closing the dome's hatch one last time. The instruments will wait. The sky will wait. Everything waits, patient and vast. And somewhere in that waiting, something begins to stir again. The first thought of what you might search for next. You step outside the observatory and let the cool air wrap around you. The night stretches in every direction. A dome so vast it humbles every thought that tries to reach its edges. The stars shimmer with quiet patience, their light arriving from times before memory. You tilt your head back, and for a long moment, you simply breathe. The comet is gone from sight now, but the sky feels different, almost aware of your looking. You can't explain why, but it feels as though something immense is returning the gaze. The thought startles you, not as fear, but as awe. You've spent so much time observing the universe through instruments, lenses, sensors, equations, that you forget how it feels to be part of what you're studying. The photons that strike your eyes are the same ones that brushed the comet's tail, the same that left their source before humanity had names. You're not merely looking at the cosmos, you're inside it, made from the same elements, moved by the same laws. Observation, you realize, is not one-sided. It's participation. You think of 3I/ATLAS again. The visitor from between the stars, now far beyond even the imagination of telescopes. It taught you to see motion in silence, to find music in the orbits of dust. But perhaps its greatest lesson is this, that curiosity itself is cosmic. When you look at the sky and feel wonder, that feeling isn't separate from the universe. It's the universe becoming aware of itself, through your eyes, your mind, your breath. The stars above shimmer faintly, flickering with the turbulence of air. but you imagine each one steady and constant. You picture the light travelling unbroken across impossible distances. Each glimmer carries a story, of fusion, gravity, collapse, and renewal. The universe isn't a void, it's a dialogue, an exchange of light and thought. When you gaze upward, you're answering a question the cosmos has always asked. Who will notice I exist? You think of how ancient astronomers once believed the stars were eyes, the heavens watching over them. Maybe they weren't wrong, only poetic. The gaze of the sky isn't one of judgment, but of reflection. When you look deeply enough, what you find is yourself, your longing to understand, your need to belong, your instinct to search for meaning. The telescope is only a mirror pointed upward. A gust of wind brushes your face. You close your eyes and let it pass, feeling how small you are, yet how infinite that smallness feels. It occurs to you that the atoms in your skin were once part of ancient stars. They burned, scattered, and gathered again, now holding consciousness, capable of wonder. You open your eyes and see the same starlight that once forged your body shining above. The circle feels complete. The observer and the observed are the same. You remember the first night you saw 3I/ATLAS, that strange interstellar light moving through the frame, unlike anything you'd tracked before. You felt then what you feel now, a pulse of recognition, as if something vast had noticed you noticing it. Perhaps that's what wonder is, an exchange of awareness, brief but eternal. You can't prove it, but you can feel it. And sometimes that's enough. In the quiet you sense more than see. The sky feels thick with presence, not of gods or spirits, but of history, physics, and endless motion. Each star is a record of what once was, yet it glows in your now. You stand between time's directions, a conscious moment suspended in infinity. You think maybe the sky watches not through eyes but through memory. Every photon reflected from your skin joins its archive. Every heartbeat adds to the music of what exists. The night deepens. You sit down on the cold ground, tracing constellations with your finger against the dark. They're human inventions, yet they hold a strange truth, an attempt to draw meaning between points of light. Maybe that's what science and myth share. Both are ways of seeing ourselves reflected in the stars. You feel comfort in that even across thousands of years, people still look up for the same reason, to feel connected to something immeasurable. You whisper softly, though no one is there to hear. The sound of your breath seems to rise into the air, dissolving among the stars. You wonder if sound too leaves an imprint, not in the vacuum of space, but in the minds of those who listen. You think of all the astronomers who have stood like this, staring upward, hearts full of questions, their thoughts, their hopes, their equations, all ripples in the same ocean of curiosity. Your gaze catches on one faint, almost invisible star near the horizon. It flickers, nearly lost in the haze, yet persists. You smile at its stubborn light. Maybe that's what life is, a brief shimmer of awareness against vast darkness, shining not to be seen, but because it cannot help but shine. The sky watches not to measure you, but to remind you that you too are part of its radiance. As the hours pass, the cold deepens. You pull your jacket tighter, but you don't want to go inside yet. You want to stay with this feeling of being both infinitesimal and infinite, both question and answer. The stars don't move quickly enough to notice, and yet you know they're always changing. You think perhaps the same is true of you. You close your eyes one last time, and the darkness behind them becomes indistinguishable from the sky above. You can't tell where you end and the universe begins. For a moment you feel seen, not by a deity, not by another person, but by existence itself. The cosmos doesn't need to look, it simply is, and that is enough to be witnessed. You open your eyes, and the first pale light of dawn begins to edge the horizon. The stars fade slowly, but their memory lingers in your vision. You realize that seeing is never one way. The gaze you give the universe is the same it gives you. You breathe in deeply, the cold air sharp and alive. Somewhere beyond that pale horizon, 3I/ATLAS continues its silent voyage, still part of this shared awareness, still reflecting the gaze of all who wonder. And as the sun begins to rise, you feel that same awareness shift within you, a quiet invitation to follow its light into the next question. Time, you've learned, doesn't really flow the way rivers do, doesn't rush past you, carrying your life downstream. It's the opposite. You are the one who drifts slow and quiet through the great stillness of time itself. Around you stars burn, fade and reappear as your motion carries you forward. The universe, vast and indifferent, keeps its rhythm without hurry. Every atom, every orbit, every memory unfolds according to this invisible current. You think of 3I/ATLAS, that traveller from beyond our sun, moving on a path so long it erases the idea of before and after. It doesn't circle back, it doesn't return, its journey is not repetition, but release, a steady glide through eras no living being will ever witness. Its motion is time itself made visible, a single line through eternity. Watching it reminds you that time doesn't belong to clocks. It belongs to motion, to change, to the soft unfolding of distance. Imagine that you could follow the comet. You would leave the orbit of Earth, the warmth of sunlight, the whisper of atmosphere. The stars around you would appear to shift, not because they move quickly, but because your vantage changes with every heartbeat. In this way, perception becomes a kind of travel. You start to see that time is the map drawn by memory, and you're both traveller and cartographer. The sky keeps no record of hours, only your awareness does. The idea comforts you. The fear of time, of running out of it, begins to fade. If everything is drifting, then nothing is truly lost. Even the moments you think are gone have simply moved beyond your current horizon. You imagine them still existing somewhere behind you, glowing faintly like the trail of a comet. Perhaps every instant of your life still lives, frozen in the light that left it. Time, after all, is just the pattern of motion, the echo of what once was, continuing forever outward. 3I/ATLAS crosses the dark regions between stars where gravity grows thin. Out there, no sunrise or sunset marks a day. The concept of now stretches until it loses meaning. The comet's pace is steady, patient, so slow that to human eyes it would appear still. Yet in that stillness, entire millennia slip by. You wonder what time feels like for something that never stops, never anchors. Does a comet know the difference between beginning and end? Or is every moment equally endless? You think of Einstein, how he described time as woven with space, inseparable, curved by gravity. You picture space-time not as a fabric but as a quiet ocean. Everything floats in it. Planet, stars, thoughts. 3I/ATLAS leaves ripples as it moves, faint distortions that travel forever, unseen but real. You too leave ripples, small perturbations of meaning, of memory. The difference between you and the comet, perhaps, is scale, not essence. Both are currents in the same ocean. The night sky above you stretches deeper than comprehension. Somewhere beyond that darkness, galaxies drift apart. Their motion too is time's unfolding, a slow expansion of a distance that carries everything further from everything else. You realize that cosmic time is not measured in seconds or years, but in separations. Every widening gap between stars is another beat in the universe's slow heartbeat. Time doesn't end, it only expands. As you watch the stars, you begin to sense your own drift within that expansion. Your body changes, atoms decay and reform, thoughts appear and vanish. You're as transient as any passing comet, yet within you is the same endurance. The molecules that hold your breath tonight once swirled in ancient nebulae. They too have drifted across eons, through the bellies of stars and the emptiness between them, to gather briefly into you. A conscious pause in their journey. Perhaps that's what time really is, not a line, but a gathering and dispersing of meaning. The comet gathers light, carries it, then releases it. You gather moments, carry them, then let them go. Both actions are the same. Both are creation. Every memory you hold is a small constellation, a pattern drawn across the drift. When you remember, you reverse entropy, if only for a heartbeat. You bring what has passed back into presence, just as a telescope catches ancient light and makes it shine again. You think of the astronomers who will someday study the fragments of 3I/ATLAS long after it's gone from sight. They'll measure its velocity, trace its course, and realize how far it has traveled. Yet even they will only glimpse part of its path, a fraction of its infinite motion. The rest is unknowable, like tomorrow, like the future's own dark sea. Maybe that's why time feels mysterious, not because it hides, but because it never stops revealing. The comet drifts on, indifferent to the boundaries of years or centuries. Its motion doesn't depend on calendars. It answers only to gravity and inertia, to the quiet balance between pull and freedom. You imagine it now, cold and silent, far beyond the planets, a faint thread of light slipping into interstellar night. Its journey is so long that by the time it reaches another system, the Earth will have changed beyond recognition. But still, it moves, not out of purpose, but because that's what everything does. It continues. You breathe slowly, matching your pulse to that imagined pace. There's peace in this drift, a letting go of urgency. You think maybe the goal was never to stop time or outrun it, but to move with it, gently without resistance. The comet doesn't fight the dark or chase the light. It simply follows the curve written for it by the laws of the cosmos, and in doing so it becomes timeless. You too could live like that, following your path without hurry, carrying light without clinging to it. The stars seem to shimmer closer now. Each one marks a different age, a different measure of time. You look up and see not one sky, but many, layers of history stacked in photons. The universe isn't a clock ticking forward. It's an orchestra where every note still lingers, vibrating through the silence. Time isn't lost, it's cumulative. You exist inside its resonance, one tone among infinite others, adding your quiet melody to the endless drift. You close your eyes and picture 3I/ATLAS as it disappears into the dark between stars. Its path curves faintly through your imagination, not a line, but a spiral, a slow turning through space and time. Perhaps it will pass near another world one day, and some distant observer will look up, feeling the same wonder you feel now, the thought makes you smile. The comet's drift continues, and through it, so does the human desire to watch, to understand, to be moved. Somewhere out there, the comet glides onward, crossing centuries like moments. Its silence becomes your lullaby. You lie back, breathe in the cool night air, and feel time stretch gently around you, not rushing, not ending, only unfolding. And as you drift with it, you sense the next question rising softly in your mind. If time never stops, what truly does it mean to return? The comet is gone. Its long arc across the solar system has ended, and with it, a chapter of cosmic observation closes. No one will ever see 3I/ATLAS again. Its trajectory is too open, its velocity too great. It will never circle back. It will never meet the sun again. It will drift into the interstellar dark, anonymous, silent, and untouchable. Yet in that disappearance lies its most profound gift. Every reading, every frame, every spectrum of light recorded from it now lives in our archives. The comet's journey has become data, numbers and images that will be studied long after the dust of its passage disperses. That's the strange beauty of science. Even as matter escapes, meaning remains. We cannot hold the comet itself, but we can hold what it revealed. Its motion, its chemistry, its souvenirs, all preserved in the quiet memory of machines. In laboratories, astronomers replay those final images. They trace the faint green tail one more time across the black field of stars. They compare its path to the ancient equations of escape velocity, orbital inclination, and angular momentum. And as they do, they sense something beyond the math, a feeling that science rarely names but always pursues: wonder. The realization that discovery is not about ownership but about connection. No one can follow where 3I/ATLAS has gone, but everyone can follow what it meant. Students will one day learn about it in textbooks that compress centuries of sky watching into a few pages. They'll see its trajectory drawn as a thin white line on a dark background, labeled with coordinates and years. Yet behind that simple diagram hides everything we ever felt while watching it: the sleepless nights, the exhilaration of detecting something unbound, the quiet awe of knowing we witnessed a visitor from the galactic deep. Even the silence it leaves behind is full of echoes. Every telescope that turns back to the stars carries the trace of that first astonishment. The instruments we build next, sharper, broader, wiser, will carry its lessons in their design. We learned from 3I/ATLAS that the universe still holds surprises, that our maps are never complete, and that even interstellar travelers can briefly illuminate the story of our own system before vanishing forever. In time, the raw data will fade into older formats. The hard drives will age, the images will pixelate, the names of those who tracked it will slip into the margins of history. But the discovery itself, the act of noticing, of recording, of asking why, that part doesn't end. It transforms. Just as the comet transformed from ice to vapor to light, its meaning evolves into memory, into culture, into quiet human curiosity. You realize then that the future never repeats, not because things end, but because they continue in different forms. Every observation is an inheritance. Every vanishing comet leaves behind a question. Somewhere, in another star system, another world may watch another visitor and feel the same fleeting recognition. We are part of something larger, something that moves and leaves traces everywhere. 3. I/ATLAS will keep traveling for millions of years. It will pass uncounted suns, unseen and untouched, a relic of frozen molecules from another age. Its data will sleep inside human servers, its name whispered in the language of discovery. And perhaps one day, when humanity itself ventures beyond this system, someone will find its faint trail again, not as a returning visitor, but as an old friend met on a new frontier. The comet will never return, but its story already belongs to the universe. It will remain in our science, in our imagination, and in the idea that no ending is truly final. The sky remembers every traveller that passes through, and so do we. The night is quiet again. The telescopes have long since powered down, the last log saved, the observatories darkened except for a few blinking indicator lights that mimic distant stars. You sit beneath the open sky, no longer searching for 3I/ATLAS, but feeling the space it left behind. Above you, the constellations stretch wide, familiar and ancient, yet somehow changed. The absence of the comet feels like a soft pulse still moving through the night, a memory written in silence. You close your eyes. The hum of the earth beneath you seems louder now, wind through grass, the slow rotation of a living planet carrying you through the dark. You breathe in, and with that breath you sense how much of the cosmos is already inside you. The oxygen in your lungs, the carbon in your blood, the iron in your veins, all born from the hearts of stars long gone. You are in every quiet way made of what once blazed. For so long you have looked at the stars as something distant, something other. But tonight, the boundary dissolves. You are no longer an observer. You are a participant in the same unfolding equation. The comet's path, your heartbeat, the rotation of galaxies, all parts of the same slow rhythm. In that realization, science and wonder no longer stand apart. They merge, perfectly balanced, as if they have always been one language spoken in two tones. You imagine 3I/ATLAS still moving, not lost, but continuing its long, silent journey through interstellar night. It carries no mission, no name anymore. It simply is, yet somehow that simplicity holds more meaning than any discovery. To exist, to move, to reflect sunlight once before vanishing. What more does anything in the universe truly do? What more do we? You picture its fading tail stretching across the distance, not as light, but as memory, a thread tying you to the vastness beyond comprehension. Somewhere that faint dust still glimmers, scattered among solar winds, whispering the story of its passage. Each particle is a moment, the instant of discovery, the wonder of its brightness, the hush that followed. Together they form a constellation too subtle for the eye but clear in the mind. Around you the world continues. The stars above remain unbothered by human awe, yet somehow awe feels like their echo. The way the universe notices itself through your awareness. You wonder if this is what all great discoveries lead to, not conclusions, but communion, a joining of understanding and mystery, a sense that knowing and not knowing are both sacred forms of attention. You open your notebook, the same one you used the night the comet was first confirmed. The pages are filled with measurements, sketches, fragments of thought. But now, instead of equations, you write a single sentence. I was here when the sky changed. The ink glows faintly under starlight. You realize that the act of recording is not just for science, it is an act of belonging. To write is to leave a mark in the story of the cosmos, as 3I/TLAS left its mark in ours. The air grows colder. The Milky Way arches above like a slow river of time. Somewhere within it, billions of other comets wander, unseen, each carrying its own ancient ice, its own secret trajectories. You imagine one of them, millions of years from now, passing another inhabited world. Maybe on that distant world, someone will look up and feel the same flicker of wonder, and for a moment, you and they will share a single thought across epochs. We are part of this. The longer you sit beneath the stars, the more the boundaries dissolve. The sky no longer feels above you. It feels like something you are inside. The space between your thoughts feels as wide as the void between galaxies. The pulse in your wrist seems synced with the faint cosmic rhythm of expansion. In this stillness, science becomes prayer, and observation becomes participation. You think of all that 3/ATLAS revealed, not just about physics or trajectories, but about perspective. It reminded you that beauty in science is not found in certainty but in curiosity. It taught you that the universe is not just a place to measure, but a story to feel, and in feeling it you become something larger than yourself. The night deepens, the stars drift westward. You lie back on the cold ground and watch the sky turn, slow as breath. Somewhere far beyond what any telescope can see, the comet continues its path, forever moving outward, just as your thoughts, your dreams, your questions do. The two of you, human and the comet, separated by scale but joined by motion, both carried by gravity's invisible hand toward whatever lies next. You close your eyes. For a moment, there is no sky above and no earth below. There is only stillness, vast, complete, luminous. You feel as though the night itself inhales through you. And in that silence, you understand what all this searching has been for, not just to find what's out there, but to remember what you already are. Your stardust that learned to look back at the stars, your gravity that learned to feel wonder, your light, slowed down into thought. And tonight, as the comet fades into endless space, you fade into the sky, not lost, but home.